Right, this is chapter 4, section 3, and we're talking about congruent triangles. You have two objectives in this lesson. By the end of the lesson, you should be able to use the properties of congruent triangles, and you should be able to prove triangles are congruent by using the definition of congruence. First, we're going to talk about when figures are congruent. They're congruent if they are the same size and shape. Corresponding angles and corresponding sides are going to be in the same position. If I have two congruent polygons, then their corresponding sides are congruent. That means that when I have triangles that are the same size and shape, they are also going to be congruent. We're going to see an example of all that on the next page. So here are my two triangles. They have the same sides that are congruent, AB and DE, and the reason why I say it in that order is because A has one angle mark which is congruent to angle D. So if I start here on this one, I'm going to start here on that one, and then I go over to angle B which has two angle marks, which means I'm going over to angle D which has two angle marks as well. BC is congruent to EF, BC and EF, and then I have AC which is congruent to DF. I don't know why that's there. Okay, so AC is congruent to DF. Here I also have a rectangle that is, one is upright and the other is lying on its side. Notice that all of the letters are color-coded. You can also tell by looking at the letters and the order that they're in which ones are congruent to each other. So P is congruent to W, that's why they're both red, Q to X, R to Y, and S to Z. So then when I have two letters next to each other, PQ is congruent to WX. PQ is congruent to WX. Basically the sides that match up. Alright, so here's your helpful hint. If I have two vertices that are endpoints of a side, those are called consecutive vertices. So if I look back at the other page, two vertices that are back to back, PQ are consecutive, QR are consecutive, RS are consecutive, SP are consecutive. So ones that are right next to each other. QS is not consecutive. Now if I'm going to name a polygon, I need to make sure that I go in order looking at consecutive points. So if I have polygon PQRS, I can start with any letter that I want. If I start with Q, I'm just going to have to go in order from points that are consecutive. So QRSP, RSP, PQRS. I just can't go at a diagonal. So if I start at S, I can't jump to Q and then do R and then to P. So PRQS, which is PRQS, do you see how I jump across at the diagonal? This is not going to work. Something for you to remember is that when you name your triangles, you're also telling people which parts are congruent, so you have to do this very carefully. The nice thing about this is that it's going to help you figure out which ones are congruent. We'll see that on the next section. Alright, so here's your first task. You're given that triangle PQR is congruent to STW. And like I said earlier, the names are telling you which ones are congruent. So angle P, because P is first, is congruent to angle S. Angle Q, because it's second, is congruent to the second one over here, which is angle T. And angle R, because it's third, it's congruent to the third on the other one, which is angle W. When I'm talking about congruent sides, I'm just going to put the letters that are together. So PQ is the first two. It's also congruent to the first two over here, so it's congruent to side ST. And then the second two, starting with the Q, is QR, which is going to be congruent to the second two here, which is at TW. And then the last one, I'm going to take the first and the last point in the triangle, which is going to give me the third side. So I've got RP is congruent to WS. Now because I went RP, I also had to go WS. If you tried this on your own and you went PR, whoops, that's congruent, is congruent to PR is congruent to SW. These two things are the same. They're interchangeable. So either one of those is fine as long as you continue to go in the same direction. If I start with the first and go to the second, or excuse me, the last, then I have to start with the first and go to the last. Alright, so here's another task. You're given that triangle ABC is congruent to triangle DBC, ABC is congruent to DBC, and you need to find the value of x, so this value right here. Because I know that this is a 90-degree angle, it's labeled in the picture, the image. I know that the definition of perpendicular lines tells me that this is also a 90-degree angle. So I know that angle BCA and angle BCD are right angles. Because they're both right angles, I know that angle BCA is congruent to angle BCD. And that's because of the definition of the right angle congruence theorem. And then the definition of congruent angles tells me that the measure of angle BCA is equal to the measure of angle BCD. Now that we're talking about measures, we're going to say equal. If we were just talking about angles or shapes, we're saying congruent. Then I'm going to substitute my values. So I have 2x minus 16 equals 90. I add 16 to both sides, so I'm adding the opposite. I get 2x equals 106. Divide both sides by 2. I get x equals 53. That's what the question was asking for, so that's my answer. Another task, similar. I have triangle ABC, and that is congruent to triangle DEF, I need to find the value of x. So AB is congruent to DE. And I know that because corresponding sides of congruent angles are congruent. Now, I know that since they're congruent, I know that their measures or their lengths are going to be equal. So AB is equal to DE. And then I can substitute their values. So I have 2x minus 2 is going to be equal to 6. I'm adding 2 to both sides so I can solve for x. 2x equals 8. Divide both sides by 2, so I'm still solving for x. I get x equals 4. And your directions were to find the value of x, so you're done. Last task, I have triangle ABC is congruent to triangle DEF, and they want you to find the measure of angle F. So F is over here. I have ABC congruent to DEF, same thing. The triangle sums theorem, now that I'm talking about angles, tells me that if I add up all the angles in a triangle, it equals 180, and that's where I'm going to start. So the measure of angle EFD plus the measure of angle DEF plus the measure of angle FDE is going to equal 180 degrees. I also know that angle ABC is congruent to angle DEF. ABC is congruent to DEF because of the corresponding angles of a congruent triangle are also congruent. So that means that this is 53 degrees. Oh, and I jumped ahead of myself there. So I have the definition of congruent angles. I have to talk about the measures. So this is the angles in general. This is about the actual numbers when I insert the measure in front of the angle. So now I can say that they're equal. So we talked about the angles in general, now the measures, and now we can insert the number. So what I said earlier, 53 degrees is the measure of angle DEF. We have the measure of angle EFD plus DEF plus FDE equals 180. We have some values now, so we can substitute in. I have the measure of angle EFD is the one that I'm looking for, so I'm going to put angle F plus 53 degrees was DEF, which is this here, plus FDE we already know is 90 equals 180. So we substituted it into this here. 53 and 90 give me 143 equals 180. I still have the measure of angle F, and then I have the measure of angle F equals, if I minus 143 from both sides, I get 37 degrees. Measure of angle F is what I was looking for, so I'm done. Alright, this is the last one. You're supposed to prove that triangle XYW is congruent to ZYW. We're going to go through this step by step, and then I'm going to show you the proof already completed because it takes me too long to write it out. But we're going to talk about it here. So it says angle YWX and YWZ are right angles. It means I know both of these are congruent to each other because they're both right angles. The next one says that YW bisects angle XYZ. If it's the bisector, then that means this angle is the same as this angle, because the definition of a bisector says that when something gets bisected, it gets cut in half, so both halves are equal to each other. The next piece of given information says that W is the midpoint of XZ. Now what does that tell us? Well, if W is the midpoint of XZ, that means that this section here, XW, is congruent to WZ. Both of these lengths are the same. The very last piece of information, given information, says that XY is congruent to YZ, which means that this side here is congruent to this side here. So we have these two angles congruent to each other, and I know that the third angle is congruent to each other because of what? Do you remember? The third angle theorem says that the leftover angle or the third angle has to be congruent if the other two are. And then I also have these two sides congruent to each other. And then I need this side to be congruent to itself. Do you remember why this would be congruent to itself? If you're thinking reflexive property, then you're right. This right here is the proof written out completely. This is the first piece of given information, and this is the picture in case you want to reference it, but you probably should have already written it down. And then we talked about YWX, YWX, and YWZ being congruent because they were both right angles. And then we used the next piece of given information that that segment was bisecting this angle, which meant that those two angles were congruent. Definition of a bisector. We said W was the midpoint because that was given, and because it was the midpoint, the definition of a midpoint told us that those two segments were congruent. And then we said that this line was reflexive and made that line congruent to itself. We said that angle X is congruent to angle Z because they were our leftover angles. The third angles theorem tells me that my leftover angle or my third angle is going to be congruent if the other two are already congruent. And we have our last piece of given information And then we were able to tell that the triangles were congruent because we proved that all 3 angles were congruent, and we proved that all 3 sides were congruent. I hope that helps. We're going to keep doing proofs. Don't forget to write your summary, and we'll talk about any questions that you have tomorrow, so please write your questions underneath your summary section.